So welcome back, dear friends. So after distillation, we will continue our next part. That is what fractional distillation. So see here, what is in that fractional distillation? If the boiling points of the two liquids which form a solution differ by only a small temperature difference, that is how much that temperature difference say less than 25 Kelvin. The fractional distillation is carried out by using a fractionating column. So whatever in addition with our this simple distillation, here we have to add fractionating column. So there are a variety of fractionating column, as we can say in our INCIT also different types of fractionating column for fractional distillation for different solvents. So see here examples: ethyl alcohol and water. The ethyl alcohol and water are miscible liquids. So see, the boiling points of ethyl alcohol is 78 degrees Celsius, and the boiling point of water, as you know, everyone knows this, 100 degrees Celsius. A mixture of ethyl alcohol and water can be separated by a fractional distillation. So see, how can we separate this? So see, method and discussion about the fractional distillation. So in that first, the mixture of ethyl alcohol and water is heated in a distillation flask fitted with this fractionating column. Okay. So next, when a mixture is heated, both the ethyl alcohol and water form vapors as their boiling point approaches respectively. So both can form vapors. So next, the ethyl alcohol vapors and water vapors rises up in the fractionating column. So as you heat this, whatever vapors, so that vapors it can approaches in this fractionating column both. Okay, so next, the upper part of this fractionating column is cooler. So as the hot vapor rises up in the column, they get cooled, condensed here, and back into the distillation flask again. So as the experiment goes on, the fractioning column warm up by the heat release. So what will happen? As the experiment goes on, the fractioning column warm up. Fractioning column what will happen? Warm up by the heat release by the condensed vapors. So when the temperature at the top of the fractioning column reaches 78 degrees Celsius, the ethyl alcohol vapor passes into the condenser and gets cooled and collects in a beaker. See here, whatever in this conical flask kept at the end of the condenser. So in this way, all the ethyl alcohol distills over and gets separated. So we will see again, same as like our arrangement, like a simple distillation flask. So here fractioning column. So when we start heating, so vaporizes reaches the temperature up to how much? 78 degrees Celsius first, then after the 100 degrees Celsius. So once 70 degrees Celsius here temperature rises, so slowly that whatever our first, that is ethyl alcohol, they are collected from this condenser and slowly back into this conical flask. So here, as you know, thermometer also they are range giving how much? 78 degrees Celsius. So like that we can separate our in our fractional distillation. So it is all about what fractional distillation column. So we can observe here one thing, uh, petroleum products. So these petroleum products are also separated by fractionated distillation. So first, as you know, petroleum products are what? Our crude oil. So once you apply with heater, then like that fractions at the fractions we are getting here what? Different our useful important petroleum products we are getting. So petrol, that is gasoline, then naphthalene, kerosene, diesel. Okay, then you have some lubricating oil, fuel oil, like that. Here what? Fractionating column for your what? Crude oil. So we in this method we separate out petroleum products by with the help of fractional distillation. So whatever our next part we will discuss in next lecture. Thank you.